Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about one more application of decrease and conquer. This is nothing but depth first search. Now first, what is meant by that depth first search? And we are going to see the steps which are involved in doing the depth first search. And example, how to search a tree or a graph in the depth first search method. Right. Now, depth first search is an algorithm used for traversing or searching a tree or a graph data structure. So here, I hope that you all know a tree data structure as well as a graph data structure. So here, the depth first search is used for traversing or searching a tree or a graph data structure. So this procedure starts at a selected node. Usually we select the root node. Initially we select the root node and explores as far as possible along each branch before backtracking. So first it goes for depth of that particular branch before it backtracking to the next level. Right. So the main idea of DFS is to go as deep as possible along each branch before backtracking. So it goes to the depth of the tree. That's why only depth of the graph. That's why only we are calling this as depth first search. It uses the stack data structure to keep track of vertices which are to visited next. So this algorithm follows last in first out approach, which is typically implemented using recursion or an explicit stack data structure. So now we are going to see the steps which are present in depth first search. So here, what are the different steps involved? First step is choosing a starting node. Select a starting node to begin the traversal. First, we need to select a starting node to begin the traversal. So I already said you that usually we select the root node, or in case of a graph, we will select one random node as the beginning node for traversal. And second step is mark the node as visited. So first we need to, since we already selected the starting node, we need to mark it as a visited node. Next step is explore all adjacent nodes. So in the next step, once the root node is marked as visited, so we need to explore the adjacent nodes of the current node, that is, which are unvisited. So we need to consider definitely the unvisited nodes which are present adjacent to the current node what we selected. So we need to apply this DFS procedure recursively. That is, we need to repeat the steps from 2 to 4 recursively to entirely search the tree. So these are the steps involved in DFS. Right. Now here, let us see, I have given an example. Suppose the traversing starts from A. Let us say that the traversing starts from A. Sorry, yes. From yes, it goes to the depth of the graph. So that's why immediately after A, S to A it goes, then A to D it goes, then D to G it goes, then from G to it can go either E or F. So alphabetically we are taking E, then it goes to B, then it goes to F, then it goes to C. Like that it is visited, right? The nodes visited in that order. So here we are going to explain 3 rules. Rule 1 is visit the adjacent unvisited vertex. Mark it as visited. Display it and push it into the stack. So every time. Now if you are present at this node, you need to select an adjacent unvisited vertex. For this node, the adjacent vertices are 3 adjacencies are there, A, B, C. You can take either A or B or C. So alphabetically, since A is first, we are considering A. Right. So that's why from S to A we are moving. So next, rule 2. If no adjacent vertex is found, pop up a vertex from the stack. It will pop up all the vertices from the stack which do not have adjacent vertices. That is, So if any node is doesn't having any, suppose here if you see B is not having adjacency. So once the search process moves from here to here and here to here, here to here, from here to here and from here to here. Once the search process moves here, now if you see B have only the adjacent of S. Since already S is visited, it doesn't have another adjacent vertices. So B is to be popped from the stack, right? After that, what is the adjacent vertex from E that we can select? Now here E is having only B also visited. So that's why F, it is having another adjacent vertex is G also visited. So that's why it is also not having any unvisited vertices or adjacencies. So E also popped. Then it goes for G. Now in case of G, it is having adjacencies D, E, F. D are visited, F is unvisited. So the search proceeds to F. So this is to be called as rule 2. And coming to rule 3, repeat rule 1 and rule 2 until the stack is empty. Right. So the rule 1 and rule 2 are to be repeated until the stack becomes empty. So these 3 rules are to be followed in the implementation. So here I am going to play a small video which gives the understanding of depth first search. Let us see that video and try to understand the procedure of depth first search. I hope that you all understood the procedure of depth first search, how it is worked. So now I am going to show you one more example how we are working for depth first search. So here this is the graph that what we considered for explaining about how depth first search works. So first we need to initialize the stack. So later in the second step, first we are going to select the root vertex or the initial vertex. Now here we are selecting the initial vertex as yes. So we need to mark S as visited and put it onto the stack. Now we need to explore any unvisited adjacent node from S. So from S, if we observe, we have 3 adjacent nodes. So we can pick any of these 3. So here in this example, we are going to follow the alphabetical order. Since alphabetically A comes first, we are selecting A. And now we are going to mark A as visited and we are passing it to the stack. Now we want to explore any unvisited vertex from A. So here if you observe, A is having only 2 adjacencies, S and D. Since S is already visited, we need to consider only D. So we are putting D onto the top of the stack and we are marking it as the visited. We are marking D as visited. Then we need to explore the unvisited vertices from D as well. So here it is having the adjacencies A, B and C. Since A is already visited, we need to consider only the unvisited vertices B and C. Now out of this B and C, we are considering alphabetically since B comes moved, we are considering B. Now we need to mark B as visited and we need to push it into the top of the stack. So after we need to select an unvisited vertex from B. So here coming to the B, it is having only 2 adjacencies S and D. So S is already marked as visited. D is already marked as visited. So it doesn't have any unvisited vertices. So it is to be popped out. B is to be popped out from the stack. So that's why the top of the stack becomes D only. Now again, we are going to visit, we are going to find any unvisited vertices for D. So here D is having adjacencies A, B, C. So A is already visited and B is already visited. So the unvisited vertex is C. So we want to push into the C to the stack. So, and then finally, C doesn't have any unvisited vertices. So we keep popping the stack until we find a node that has an unvisited adjacent node. So we popped the stack. So then the items that we visited in the order are S, A, D, B, and C. Right. So this entirely gives the depth first search method using decrease and conquer process. Right. So I hope that you all understood how depth first search works. In the next class, we will see breadth first search and other applications of decrease and conquer. Thank you for listening.